Hi students, today we are going to discuss another important topic, that is RSA algorithm and configuration of firewall. There is a basic essential steps for configuration of firewall. So let us first discuss what is public. Today our agenda is discuss what is the today objectives here, introduction to RSA algorithm and firewall, and how this RSA algorithm is working. That is demonstrate the working of RSA algorithm. That is how to generate the keys, and next one is how to encrypt the how to encryption and how to decryption, and next one is configuration of firewall. This is, and based on these concepts, what is the learning outcomes here? Describe the concept of public cryptography and process of RSA algorithm with examples. Describe the concept of firewall and configuration of firewalls. So today my agenda is, this is today agenda. First one is introduction to public key cryptography. Right? What is cryptography? Already discussed in previous sessions. And what is the different types of cryptographies, that is symmetric type and asymmetric type. There is a two types. And next, this RSA algorithm comes under the public key cryptography algorithm, that is asymmetric type. Right? So what is the basic concept of public key and public key cryptography? Next comes under the RSA algorithm. So basics of RSA algorithm, who was developed by this RSA algorithm, we will discuss later. And there is a main three essential steps. So first, key generation. In public key cryptography, there is a two key generation algorithm. We need to generate two keys. One is public key, next one is public key, next one is private key. Right? After getting two keys, after generating two keys, next step is we can do encryption process. That is, encryption means ciphertext is converted into, plain text is converted into ciphertext. This is plain text. Plain text is converted into ciphertext. This is encryption. This is, we call it as encryption. So in reverse process, ciphertext input is ciphertext and converted into original message, that is the plain text. This is, we call it as decryption. This is, we call it as decryption process. After completion of this RSA algorithm, we will discuss firewall. So what is a firewall? We'll show that diagram, and what is the basic essential steps for configuration of firewalls. So that is, we will discuss in next coming slides. Right? First, RSA algorithm. Right? Before RSA algorithm, what is it? Is a asymmetric algorithm, that is public key cryptography algorithm. So what is public key cryptography? What is cryptography? It is the process of hiding information. It is the process of hiding information. What is cryptography? What is cryptology? What is cryptanalyst? So these, what is the plain text? What is the basic diagram of this cryptography? These all topics are discussed in previous sections. Right? Go through those sections. So public key cryptography is the cryptographic system that utilize two related keys, that utilize two keys. So basically it is a asymmetric cryptography algorithm. So cryptography, public key cryptography, or we call it as asymmetric key cryptography. In this asymmetric key cryptography, we use two keys. One is public key, next one is private key, next one is public key. This public key is used in one side, this private key is used in another side. That means one side means this is sender here, see the diagram, this is in sender side, alias is sitting in sender side, Bob is sitting in another side, that is a another side means that is receiver side. So alias is want to send one message to Bob. Now this is original message is a plain text, original message is a plain text. This place, before transferring this message, first we need to do one thing. This plain text is converted into ciphertext. Then only this ciphertext only transfer through network. This is network, this is in middle, this is network. Through internet we can transfer this ciphertext. So we don't send original message. Instead of original message we send this ciphertext. How this plain text is converted into ciphertext, that is the encryption process. Different algorithms we are using. There is symmetric algorithms are there, asymmetric algorithms are there. Now this RSA algorithm is asymmetric algorithm, that's why we are discussing here public key cryptography, right? So here there is a two algorithms we need to develop. This is public key, and we need to generate two keys. One is public, another one is private. This public key is used in sender side, private key is used in receiver side. Right? Now go for RSA algorithm. This is a RSA algorithm. This algorithm developed by three scientists. First scientist name is Ron Revest, second scientist name is Adi Shamir, and third scientist name is Len Edelman. These three scientists are developed by this RSA algorithm. So their first names are here, I am underlining R, S and Edelman, right? So based on these three scientist names, based on this algorithm, his name came from their names. That is a RSA algorithm. It will generate two different types of keys. That is, one is public key, second one is private key. It is a asymmetric type of algorithm. So in encryption side, encryption is done using public key and decryption is done using private key. In encryption side we use public key, in decryption side, that is the sender side, we use public key, in receiver side we use private key. And in secure communication and various other cryptography operations without the need for a shared secret key. Here advantage is we no need to share any secret key. In previous sections to discuss DS algorithm, AES algorithm, these all are symmetric algorithms. That means in sender side and receiver side, both side use same key, right? But it is a asymmetric key. So in that algorithms, DS algorithm, AES algorithm, there is a one key used in both sides. That's why this secret key is shared between these two persons, that is sender and receiver. But here no need to share any secret keys without the need for a shared secret keys, right? That is the advantage here. Next one is the public key is the public key is shared openly, while the private key is kept secret by its owner. That means each and every user need to generate two keys, right? One key is public key, that is open for all members, right? This is open for all members. Any person can able to see that public key. But private key is kept secret by its owner. That means all persons no need to share this private key. So he need to kept secretly. Now discuss how these keys are generated. That is, the keys are means, that is, one is public key, next one is private key. First, basically you can select any two prime numbers. That we call it as P and Q values, right? Remember values, that is P, Q are prime numbers. You can select any prime number. If you are selecting large numbers, that is more secure. You can provide more secure. If you want to provide more secure, you can select the large number of prime numbers, right? You can select any prime numbers. For example, 5, 7, 11, 13, 17, you can select any prime number. But these both numbers are not equal. P not equal to Q. So P not equal to Q. Now calculate n value, that is modulus value, that is compute the modulus value, that is n equal to P into Q. Now based on the Euler's torsion function, you need to find out pi n value, torsion value, that is torsion value formula is p minus 1 into q minus 1, p minus 1 into q minus 1, right? Up to now this is p value find out, q and n and pi n. Now another two values we need to find, that is, one is public key, public exponent selection value, that is e value. E is a relatively prime to pi n and less than pi n, that is e. You need to select this e value based on the formula, that is GCD of e comma pi n should be equal to 1, e comma pi n value equal to 1. That is the formula of this GCD of e comma pi n equal to 1. So you already get this pi n value here, right? You can select this e value, you can select this e value based on this pi n value. This should be greatest common divisor of e comma pi n equal to 1. That formula should be satisfied based on your e value. Now calculate the, after selecting e value, now calculate the, that is private exponent calculation value, that is d value, e into d mod pi n equal to 1. This is the another formula, e into d mod pi n equal to, already you get in above step you got e value and you know the pi n value, right? Now calculate the d value based on this formula. After getting these values, actually first one is p value, q value, this is p value, q value, then you can calculate pi n value, then you can calculate pi n value, select e value, then calculate the d value. Based on these 6 values, out of these 6 values we use in e and n value only in encryption process. This is in encryption process. This is a en value is public key values. Encryption process we use this public key. This is en value. And in decryption process, instead of this en value, we use dn values. We use d comma these two values in decryption process. Right? So this is first step, that is out of 3 steps. First step is key generation, then encryption, then decryption. Now we will discuss, after finding these two keys, public key and private key, that is go for encryption and decryption. In encryption process we use public key equal to, that is public key equal to 2 values. We use 2 values, e comma n value. In private key used in decryption process, that is d comma n value. Now encryption calculates to encrypt the plain text message, then find out the ciphertext based on this public key values. So formula is C is ciphertext, get the ciphertext, M is plain text. So M is the plain text, E is the here public key, one of the value in public key, that is E, M power E mod n, M power E mod n. So this is the formula 2. After executing this formula you can get the C value. C value is ciphertext. In decryption side, that is the receiver side, we need to do in reverse process, means in decryption side we use private keys. So and this based on this private keys and based on this ciphertext value we can recover the original message, that is the plain text, right? So but in the recipient side we need to perform this operation, that is the, you know, the ciphertext, that is ciphertext, you know, you get the ciphertext, and in private key that is d and n value, and C power d mod n, you will get the message, that is M, original message, you can get this original message. If you are getting different values, you got the wrong answer. So if both values are right, then your algorithm, your process is right. So there is 3 steps. First step is generating 2 keys. Now encryption, decryption. Now go for this is RSA algorithm. Same steps are included in one slide. So first select the PQ values. P and Q both are prime numbers and P not equal to Q. P not equal to Q. Now calculate the n value. N equal to P into Q. Calculate the pi n value. Torsion function, that is Euler's torsion function we are using here. Pi n equal to P minus 1 into Q minus 1. Just simple formulas. Now select the one integer value, that is E value, based on the greatest common divisor. Greatest common divisor. Greatest common divisor of pi n comma E should be equal to 1. Should be equal to 1. Now calculate this D value based on this formula. D into E mod pi n equal to 1. Then these two are public keys and private keys. Now second step is encryption process. So in encryption process we need to find out ciphertext. So in sender side knows the M value, that is plain text, original message value, original message power E mod n, original message power E mod n. In encryption side we use one key, that is public key. Public key values are E comma E n. In decryption side we use private key, that is private key value equal to, that is D comma E values. D comma E values. Now this is ciphertext. In decryption side we need to find out plain text. Plain text formula is original message equal to, that is message equal to this value, message equal to C power D mod n value. Now go for one example. So you can select any prime numbers. This is here I taken P equal to 17 and Q equal to 11. Both are prime numbers. Now calculate the n value. We need to find out total 6 values. P comma Q value, 2 values we got. Now n equal to P into Q, that is 187. And based on Euler's torsion function, that is pi n value, P minus 1 into Q minus 1. Finally we will get P means 17. 17 minus 1 equal to 16. Q means 11. 11 minus 1 equal to 10. 16 into 10 equal to 160. Now select E value. Formula is GCD of E comma pi n equal to 1. Equal to 1. That means here 160. Here GCD means greatest common divisors. For example, 160 divisors are 1, 2, 4, 5, 8, 10, 16, 20, 32 and so on. There is so many divisors are there, right? We can select one divisor, one value. That value and 160 value should be greatest common should be a 1. So here I am selecting E value equal to 7. 7 divisors are equal to 1 comma 7. 1 comma 7. 160 divisors equal to 1, 2, 4, 5, 8, 10 and so on. Any number, so on up to 160. So this is it. So common divisors 1 and 7. Here there is no, here numbers, so many numbers is there. So common divisor equal to only 1. So that's why I select here 7 value. What is the E value? 7. Now comes on to the determine, that is calculate the D value. Calculate the D value. So here formula is DE mod 160, that is pi n value 160. DE mod 160 equal to 1. Mod 160 equal to 1. Here once we need to get 161 or 321, any value we need to get. Here 23 into 7, 20. If we are E value already find out, that is 7. 7 value is there. E value is 7 value. Now calculate the, based on the this formula we can calculate the D value, that is 23. Here 23, I take 23 value. 23 into 7 equal to 161. 161 mod 160 equal to, that is remainder equal to 1. That's why I selected here 23. Selected here 23 based on the formula. Now we got all values, p value, q value, n value, and pi n value, e and d, total 6 values. Now out of these 6 values we use 2 values for public key, another 2 for private key. One is e value, use e value and n value used in public key, and this 23 means d value and n value used in private side. That is, public key is used in encryption side, and decryption side we use public key. Now what is the encryption formula? C equal to m power e mod n. For example, n equal to m equal to, that is original plain text equal to 88, m equal to 88. Now based on the formula, this is 88 power e. 88 power e means 7, 88 power 7 mod 187 equal to, you can get the 11. Now in sender side, 11 is transferred to destination. This is 11 is the C value. C value means ciphertext value. Now in destination side, based on private key, we need to decrypt this ciphertext value. So what is the formula? M equal to C power D mod n. C value equal to 11 power 23. 23 is the D value mod 187 equal to original 88. Here original message is, what is that? 88. Here original message, we can finally get the 88 values. If you are not getting these 88 values, there is some problem in your calculations, right? So this is one example. So generating keys, here another example, generating keys p equal to 13, q equal to 11, and calculate the n value, that is 143, pi n value, that is -1, 120. Now select the e value, that is e should be 13. Here I taken 13, greatest common digit of 13, 120 equal to 1. Here calculate the d value. Based on d value, here I am using, if I select I equal to 1, d equal to 1, then I got 9.3. If I equal to 2, I got 18.5 value. Here this is the another way you can calculate this d value, pi of n into I plus 1 divided by e value, right? Divided by e value. If you are selecting I value equal to 13, then 27.7. There is fractions are there. If you are selecting I value equal to 4, then we will get 37. So there is no fractions in this numeric number 37. So we can select the d value equal to 37. Now these two values are p and q values, and third value equal to n, fourth value equal to pi n value, fifth value equal to e value, and final value equal to sixth value equal to d value. Total 6 values we need to find out. Then encryption. These two are encryption process. In 13 and 143, this is e value comma n value. This is d value comma n value. Right? Now after generating these two keys, go for encryption. C equal to m power e, that is m means original message. Here I write p power e, p means plain text, right? You can write any p or m. So choose plain text equal to 13, 13 power 13. What is 13? 13 power, what is the C formula? C equal to, that is original plain text. Here we p equal to 13, so p power e mod n. So here e value equal to 13 and 143, that is n value equal to 143. So this is e value and this is n value, e value and n value. Based on this formula, we get C equal to 50, C equal to 52. Now in decryption process, same reverse process, C value equal to 52. So 52 power 32, that is d value equal to 32, n value equal to 143, same value. So not a 32, this is 37. This is a 37. D equal to 37, n equal to 143. So 37 mod 143 equal to, you can get the 13, that is the original message. original message. Otherwise, in any way, that is some error occurred in between in calculation process. So finally we get this p equal to 13. We can perform this some exercise, that is a RSA exercise 1 algorithm, that is a this process is there. Some exercise 1 different go for in textbook in last exercise content we got the number of problems, right? Here given p value, q value, so p value given, q value given, right? Next one is e value given, that is e value given. Next one is plain text, that is plain text, original message given, original message here given. So out of 6 values given 4 values, we need to calculate the remaining values. Not this is out of 6, this is original message, that is the original message. Out of 6 values, in problem given 3 values, we need to calculate remaining 3 values. Those are what is the n value, those are what is the n value, and next one is pi n value, calculate the pi n value. Next value, e value already given, we need to calculate the d value, we need to calculate the d value. Based on pq we get the n value, that is n value equal to 7 into 17, that is 119 value. Pi n value equal to, we will get the pi n value equal to 96, that means 7 minus 1 into 16, 17 minus 1, 16 into 6, 96. Now calculate the d value. So here d value equal to, what is the formula? E into d mod pi n equal to 1. Here given already e value given, that is 5, so 5 into some d value, we need to find d value, mod pi n value equal to, pi n equal to 96 equal to 1. Now calculate this d value. Here now calculate the dn value equal to, that is based on value, that is if we are putting here 77 into 5 mod 96 equal to, should be 1, that is d value equal to 77, d value equal to 77. Based on these values, we can I am writing here, based on this value I am find out the ciphertext value, that is c equal to m power e mod n power e mod n. M value equal to already plain text given, that is 6 power e value already given, e value equal, where is this? 5, 6 power 5 mod n value, here we calculate n value, that is 119, that is value we will get 41, that is 41, sorry, that is 40, we will get the 41, that is c value. Now calculate the m equal to c power, c value equal to 41 power d, here got 77 mod n value equal to 119, then we will get the original plain text, that is original plain text is 6. Original plain text is in exams they will ask like this questions, right? We need to find out that is calculate plain text value from ciphertext and ciphertext value according to the RSA algorithm, right? Like that we need to calculate this c value and m value. So I will go here mention, I will go different problems, exercise problems here. I change this p value, q value, m value. Based on this we need to find ciphertext and encryption text and decryption text, that is the original m. So can practice these 5 exercise problems. Now comes into the another concept, that is firewall. What is the firewall? What is the firewall? Here network firewalls are devices that are used to prevent private networks from unauthorized access. Actually, we all devices or all PCs are connected to internet. So in internet there is so many users are there. So those users are some persons are thieves also is there. So another is persons, but they are access to your systems without getting the permission. So that means, so that's why we need to protect our devices, protect our organization. We need to establish we need to configure the firewalls. So this firewall is mainly used to prevent private networks from unauthorized access. Unauthorized access. So unauthorized access means either softwares or can manually users enter into your network and get the some messages, some access, you will get the some services, right? So this firewall is main advantage is to filter all incoming packets entered into the your organization, entered into the your server or entered into the your devices, what maybe it is. A firewall can be used to deny access to specific host or specific services. You can prevent any particular service also, right, in our organization. Service means HTTP service or any another service, www service, any services you can prevent any service also. Firewalls block incoming malwares based on set of pre-programmed rules. In that is the in organization there is vary the rules, set of rules. Before configuration we need to write the rules. Based on that rules we can configure the firewalls, right? These rules, based on these rules, can prevent users, unauthorized users within the network from accessing certain database or certain files, right? So this is the diagram of firewall. So this is the firewall, this is our network in organization. For example, this is our organization, this is organization contains the private network, this is all our network. So through internet you can access any other devices, or you can send any files to in any other organizations, or you can access network files through internet. So here unwanted traffic, this firewall main advantage is used to stop this unwanted traffic, means malwares or any unauthorized users. This firewall should be a stop in incoming packets, right? It will permit this traffic. Authorized users only it will permit into the our network. So essential basic steps for configuring firewalls are, so here first one is the importance of firewall configuration, safeguarding your business from cyber threats. There is a minimum 6 rules are there to configuring your firewall. Final one is that is the configuration. Based on before configuration, that final after deploying successfully firewall in our organization, we need to monitoring this we need to monitoring firewall. First step is identify network assets. This is identify network assets. First step is identify the network assets. So here identify your network assets. What is the main servers are there? What is the main devices we need to protect devices? And what is the main there is a group of systems are there. We need to provide this group of systems more assets than other systems. We need to provide these networks, including servers, devices, or any applications or any services. Organize these assets into some groups based on your sensitivity and functions, and some groups. We need to divide these number of groups. Then go for architect firewall zones and IP addresses. Now create number of zones, divide into number of zones. That is for example server zones for non web based services, and server zones for some zones for non intent accessibility services. Based on your services, you need to divide the firewalls. Then step 3 comes into the step 3, configure access control list, and set the, here in second step, set the IP addresses also. Based on your zones, you can set the IP addresses, internet protocol addresses to each zone, and implement the network address translators, and implement the, divide the subnets and subnet masking, and implement the that is divided into VLAN, virtual LANs, create the virtual LANs. These all concepts comes under the in step 2. Then access control list. This is configure access control list. This is main essential for service to block the this is main building block for your firewall rules, and they determine which traffic is allowed. Into to access the particular service or to access the particular device, and create it outbound and inbound bounds also in based on the your IP addresses and port numbers. And next one is configure other firewall services and logins. Other services, that is a DHCP service, NTP service, IPS services. You can, there is so many services are, you can configure other services and login. Set the login and password for management purpose. We can set this one. Then before deploying, we need to do this fifth step, that is testing. Test firewall is whether this firewall is correctly working or not. Whether this firewall is blocking traffic, your unauthorized traffic or not. Before deploying, we need to do this one. After that, we can deploy the your firewall. That is, firewall is up and running, and maintenance is very crucial for after deploying. After deploying also we get some errors or get some problems after deploying also. So for management purpose, you need to configure, you need to managing or you need to maintaining these firewalls. That means regularly you can update the firewall, and you can monitoring the logs, and you can review those logs, and you can review the configure rules. You can and sometimes you can put the some rules, and you can avoid the some rules. So you can monitoring these rules in each and every 3 months or 6 months. You can monitoring this. You can change these rules based on your organization requirements. For to provide for final one is to provide production purpose. These 6 rules are basic essential steps to configure firewalls. Right? So summary of this content is, that is public key. What is the public key? What is the asymmetric key? There is 2 keys. This is a 2 keys generation, public key and private key. And what is the RSA algorithm? There is a 3 steps. Generate the first there is 3 steps. First, generate the public key and private key. Next, second step is encryption, how to encrypt the data, and third step is how to decrypt the data. Then final one is what is the firewall and essential steps for configuring the firewalls. So there is the 6 steps we discussed in this session. So some self-assessment questions are there. This is the example public key, how to generate the RSA, and this is the one example. You can practice this one, right? This is another one. You can practice this one. This is the basic terminology and basic questions from this one. So reference books are, there is a data communication networking and computer security, that is a 4gen, or we can William Stallings, cryptography and network security, William Stallings. That is 4th edition, 5th edition, 6th edition, go for that. Thank you.